All right, so to finish up section 3.2, we're going to look at our z-score formula. Only this time we're going to go in a couple of these cases in reverse. So we can also find an observed value using the z-score if we are given the mean and the standard deviation of the distribution. So what I'm going to do here is just kind of show how we come up with this formula algebraically. So our basic z-score formula, remember, was x minus x bar over s. Right? We take our observed value minus the mean divided by our standard deviation. Now, if I want to rewrite this formula and get this x all by itself instead, well, the first thing I have to do is get rid of this s. So I'm going to multiply both sides of my equation by s. On this side, they're going to cancel. On this side, we're going to have z times s, and we're just going to be left with x minus x bar on our other side. Right now, if we want to get this x all by itself, we still have to get rid of this x bar. So we're going to add x bar to both sides. Right? Again, those guys cancel. And what we have here then is we have x bar plus zs equals x, which is exactly our little formula that we see right here. Right? So we're just taking our formula, rewriting a little bit to give us a different way of solving to look for a different desired value. So we're going to use both our basic z-score formula and this observed value formula as we go through this example. So going through example 2, the Public Health Service found that for boys age 11, the average height was 146 centimeters and the standard deviation was 8 centimeters. So we're using the same information that we have before. Again, one tiny little typo there, I apologize. All right, so to start with, what is the z-score of a boy who is 162 centimeters tall? All right, so our formula for z-score, remember, is x minus x bar. We can put this in parentheses if we want to, as we're putting it into our calculator, divided by s. And that's actually going to be the same formula that we're going to use for A through D. So all of these are asking for either a z-score or a measurement in standard units. So we see either of these, that should tell us automatically that we want to use our basic z-score formula. Okay. All right, so I went ahead and just filled that in. Now we're going to go through and answer these questions. What is the z-score of a boy who is 162 centimeters tall? Well, 162 centimeters is our observed value minus our mean. The average height was 146 divided by our standard deviation, which was 8. This is going to give us 16 over 8, which is going to be 2.00. Right, a boy who is 125 meters tall, 125 centimeters. 125 minus 146. Notice that our observed value still comes first. It is smaller, so we are going to end up with a negative number here, which is correct because our value is less than our mean. That's going to give us negative 21 over 8, which is negative 2.625, which then we're going to round to negative 2.63. Notice that this z-score value is more than 2 standard deviations away from our mean. So we're going to say that this one, right, would be unusual, right, because we're more than 2 standard deviations away from our mean. Right, C and D ask for our values in standard units, still using our z-score formula. So 138 centimeters in standard units, 138 minus 146 over 8. Again, observed value comes first. We get a negative number. Negative 8 over 8 gives us negative 1.00. Our next one, we have 148 minus 146 over 8. Right, it gives us 2 over 8. Which gives us 0.25. Again, if you are plugging these into the calculator all in one step, make sure you put parentheses around the top. I haven't really bothered because I'm doing the subtraction first. So A through D, if we're asked for a z-score, if we're asked for standard units, we're using our basic z-score formula. Now notice that E and F are slightly different. E and F say how tall is a boy with a z-score of 2.5, what height is negative 1.2 standard units for F. So that means that we are looking for heights. We are looking for observed values. So what we're going to use in these cases is we're going to use that alternate formula that we have up at the top of the page. So X equals X bar plus Z times S. Right? And for both of these, oops, I'm trying to put an extra bar on my X's here. X equals X bar plus ZS. Right? When we're doing these problems, we do want to make sure that we're going to label them correctly at the end since we are being asked for an observed value. Right, so how tall is a boy with a z-score of 2.5? Right, well, we're going to take X bar, which is our mean, so 146, plus Z, well, that's our 2.5, times our standard deviation, which is 8. Again, we can plug this into the calculator all at once, or we can work it out in 2 steps. If we do it in 2 steps, we get 146 plus 20, which gives us 166 centimeters. Again, as we're looking at these, we want to make sure that we are labeling our answers since we are being asked for observed values using our original units of measurement. All right, and then for this last one, again, X bar 146 plus negative 1.2 because our z-score is negative times 8. So we have 146 minus 9.6 gives us 136.4 centimeters. Right, so as we're working through these problems, we can answer a variety of different things. So remember, we did start this section talking about our empirical rule, and then from our empirical rule, we go a little bit deeper and we start looking at our z-scores. So we start looking at not just our even number of standard deviations away from our mean. We look at that in a little bit more detail here.